So we've talked about calculating first derivatives of implicit functions. What we need to be able to do is go beyond this and calculate second derivatives and higher if necessary. Now, we know the basic technique for calculating first derivatives of these styles of functions. We write it out, we take the derivative of each term, and we have to use some of the rules that we've covered before, so chain rule, product rule, quotient rule, etc. We then group together every term with a dy by dx, and then every term without, separate them on both sides, and that's how we calculate the first derivative. The second derivative follows the same style, except there's one or two extra little parts we have to remember. Now, the first of these is that we want the derivative to be expressed in a power all of its own, i.e. d2y by dx squared. So the big thing we have to remember is that if there are any first derivatives in this second derivative expression, we can get them out via substitution. Because we've got an expression for dy by dx, we can substitute that in and get that out that way. Well, let's look at an example, because that's the best way to do it. So imagine I want to find the first derivative, dy by dx, and then the second derivative, d2y by dx squared, of x squared plus 2xy equals 1. So for the first derivative, first thing we do is we just work our way along, taking the derivative with respect to x of each term. So we'd end up getting 2x, then we'd have plus 2y, then plus 2x dy by dx, and that all equals 0, because derivative of 1 is 0. So now we separate everything without a dy by dx and stick it on this side here. So I'd end up having 2x dy by dx equals negative 2, and I'm going to take it out as a common factor here, bracket x plus y. And what I'm then going to do is divide through by the 2x, so I'm going to have dy by dx is equal to negative bracket x plus y all over x. Cancel out the 2's when I divide through, and I've got it there in its simplest form. So now I know dy by dx, I know an expression for it. I now have to calculate d2y by dx squared. Now, for this sort of format here, this is where we use the quotient rule. Derivative of the top times the bottom, take away derivative of the bottom times the top, all over the bottom squared. So if I do derivative of the top first, what I end up getting is I get negative 1 plus dy by dx. That's then going to be multiplied by x. I'm then going to take away derivative of the bottom, which is just 1, and it's going to be multiplied by this negative x plus y, and that's then all going to be over the bottom squared, so all going to be over x squared. What I now have to do is simplify and sort all of this. Now I know an expression for dy by dx, so if I focus just on this bracket here, what I can do is rewrite that as negative 1, it's then plus dy by dx, but in this case it's going to be minus, and I'm actually going to keep it in the brackets to begin with, minus x plus y all over x. And if I then take it all out of the bracket here, put it all over a common denominator, what I end up getting is minus x minus y all over x. So I get minus 2x minus y over x. So that's this first part here. Now I've got that, and it's going to be times by x. That's going to multiply by x, which will simplify to leave me with minus 2x minus y. I've then got this last part here that I have to bring into play. So it's going to be this, take away negative this, so minus minus becomes a plus. So it's then going to be minus 2x minus y plus x plus y. What that then is going to equal is just quite simply minus x. So I can then substitute that back in for my numerator, and I know that d2y by dx squared is equal to my new numerator minus x over x squared, and I can simplify it to minus 1 over x. So there you go. That's my second derivative of this expression here. All I've done, calculate the first as we did before, then calculate the second. I've had to use the quotient rule. 9 times out of 10 with the format, that will probably be the type of rule you have to use, but I've also brought into play the chain rule and the product rule there. This second derivative calculation is actually quite straightforward. It's just a small extension of the first derivative. We just have to do it again and remember to substitute when we need to get rid of the first derivative. We want it written explicitly as d2y by dx squared without a dy by dx in there. Once we've found it, job done, we can use it.